Hi everyone, welcome back to another Hackerrank series, and today we are doing a question on inserting a node at a specific position in the linked list. So we have been doing a bunch of linked list questions, and it's not like I'm purposefully choosing them. It's just next in the line in the Hackerrank series, and learning about linked lists is good practice. So let's go ahead with it. In this question, they gave us a singly linked list, and in my opinion, whether it's a single linked list or double linked list, it's just one more additional layer of complexity. It doesn't really make our life easier or harder. So in depending on some circumstances, we might need it to be having a doubly linked list might be helpful, and sometimes it might not. So anyways, this question is basically saying that they have a linked list like this, 1, 2, and 3. And when they say position 2 and they want to add a data 4 in it, so it'll be 0, 1, 2. They want a 4 in this position. So it'll be 1, 2, 4, and a 3. Something like this. So to do this, it seems quite straightforward, right? Like we just traverse through the linked list, find the position that we are looking for. And once we find it, we just append it to this and make this node point to the last item or whatever this tail is. So it's quite a straightforward question, but there are some steps that we need to be careful of. So let's go get straight to it. I don't like LL list, so I'm going to do this. So one thing that we need to know, okay, before coding, let me explain the pseudocode first before jumping straight into coding it out. I guess this is the pseudocode. Do I need to explain anything else? Okay, yep. We need to understand how they have actually organized it. So it's good to always read through what are the helper codes that they've given, like how is the class defined? Is there something that we need to take note of? So they are inserting into a linked list using this method. And we can just take reference from this to like understand how to add our own linked list. I mean, our own new node, because this node does not exist. We cannot just say add 4 to it, like append 4 or something. That is not possible in linked list. We need to create a node and then add it to this. So in order to create a new node, we need to call this class. So call this class and then just put a number inside, and it creates a empty, like a node with an empty next. So yeah, that is pretty straightforward. I think we can just jump straight into coding it out. So one thing that we need to take note over here is there are two possibilities. Let's say we have a node like this, 1, 2, 3. And if they say position 0, that means the first item. We need to create a node. So whatever node, like let's say 4, and then point to this and we are done. There's nothing else that we need to do. We just need to point this to it and we are done. But if it is somewhere in the middle, we have to employ a slightly different variation of this. So it will be 1, I'll go to 2. And once I know the next item is the position that we're interested in, which is like position 2, I need to save the 3 into some temporary variable, point this to for the node 4, and make the point node 4 point to 3. So depending on where the position is, we have two different approaches. So we would have to employ like a if-else kind of a dividing thingy. So let's do that. First thing that I'm going to do is I'm going to create something like this. And if position is equal to 0, I'm just going to create a new node. So I think for creation of new node, we can just create it over here. So let's say node is equal to singly linked list and put data over here. So this is a new node that I've created that has to be attached at some point, either through if it's at the front or if it's at somewhere in the middle, it doesn't matter. But if it's at the front, our life is slightly easier. All we need to do is node dot next is equal to head, and header is equal to node. Okay, so I'm making node refer to the whole header thing, the whole head thingy. And then I'm just making sure header refers to this item, the node. That way we know that because at the end of the calls, like after else I'm doing something, I'm going to return header. So yeah, that's all we need to know for that. The next item is slightly different, which would resemble a normal linked list traversal. So what I'm doing is I'm doing something like this. How do I know that I've reached the position that I'm interested in? For that, I can either use a while loop, but I think a faster way to do this would be I mean, not a faster way, but more visually easier way to do this would be to use a for loop. For I in range, whatever position that I want, let's say position 2, I'm going to go 1 before that. So let's say position 2, I'm going to find, I need to get this item and then refer to the new node that I've created. So how do I do that? Let's say position 2. I'm going to 2 minus 1, which is 1. So I just need to traverse once. So header, head is equal to head.next. That way, my head now refers to 2. And then I can just do head.next is equal to node. So whatever this head is, it's going to, like, I'm basically first traversing until I reach the position right before the position that I'm interested in. So in this case, 2, I would need to go to index 1, like so-called index 1. And then I'm making sure this index's next is the node that I'm interested in. And nodes next. Sorry, I should first do nodes next, right? Let's do that first. Okay, I'll do this first. First thing that I'm doing is nodes next is going to be, oh wait, I need to store whatever value that I have over here into next, into some temporary file thing. So temp is equal to, interesting. How did I do this? Okay. My bad, it doesn't go over there. Before I even assign anything, I need to first store the temp value. So temp value is going to be head.next. Like before I assign to for, I need to make sure that this value is being saved somewhere. So this value be temp is equal to head.next. And after that, I'm doing node.next is equal to temp and head.next is equal to node. So nodes next will be whatever I saw saved in the temp storage, while heads next, that means this values next will be node, will be the new value that I created. And since it's already connected, it forms this nice connection over here. Now, the thing is, header always refers to head. That means it always refers to the first item. I have not changed that. This reference is still intact. Whatever happened over here doesn't matter. This is a different head from this head over here. So all I need to do is, since the header is still referencing the first item, I can just call header and wrap up this whole thing. In the first condition, header is referring to a new node, like a new item. And that's why we are doing this thing over here. Like header is referencing a new node, like a new starting point. But in this case, the starting point is still the same, which is the first head. But the subsequent points, even though I change it over here, doesn't alter this value. Hence, head.next is equal to node, still make sure it only edits the subsequent parts while retaining the initial node, which is 1, because 1 is still referencing 2, and 2 is still 2 will now be referencing the new node, and so on and so forth. This is possible because these are object instances, and they work slightly different from how you would assume a variable would react. So let's run the code for this and see if it works. So yeah, this works as well. And yeah, let's submit the code. I'll clear my drawings. And wonderful. It passed all the test cases. And hope you guys enjoyed this video. I certainly enjoyed going through them and thinking about this question again. So yeah, this was inserting a node at a specific position in a linked list. Hope you guys enjoyed the video, and I'll see you guys in another video. Bye.